What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are continuing with the trend of solving SAT problems straight from the source from Khan Academy. So here we go. And today, sorry it's such a late live stream, but I want to make sure to get it in on the Wednesday. Do a quick sound check. We're good to go. And we are going to hit interpreting nonlinear expressions. These are especially tricky problems because whenever you're talking about interpretation, I feel like it's more complex than solving. You really have to understand what's going on. So let's do it. And this is actually an equation here, but okay. Reem is a test driver for an automobile company. The following formula gives the total distance d in feet that Reem drove a luxury car in the first t seconds after idling at a speed of 0 miles per hour, up to the time when she passed a particular safety cone. Okay. Compared to the time it took Reem to pass the safety cone, how long did it take to pass a sensor that was 4/9 of the distance from the start? Ooh, there's a lot going on. Hold on, I need to break this down more carefully. Reem is a test driver for an automobile company. The following formula gives the total distance d in feet that she drove a luxury car in the first t seconds after idling at a speed of 0 miles per hour up to the time when she passed a particular safety cone. So d would be the total distance, and once she passes that total distance, she's passing a safety cone. And then compared to the time it took Reem to pass the safety cone, the time it took Reem to pass the safety cone, we'd have to isolate t. How long did it take to pass 4/9? Okay, so I think I get what they're saying. We need to figure out 15.69 times t squared. We need to compare the t here to the t here. T squared. Okay. Now this is where it's passing 4/9 of the distance to the start. What I can tell you is this: we could isolate. We could do all that stuff. We could divide by 15.69. Divide by 15.69. Okay, and we do the same thing here, right? 15.69, 15.69. But that doesn't really matter because we're comparing across these two times. Let's call this T1 and T2. We're comparing these two times. Then we need to take the square root of both sides, all right? So same thing here, same thing here. Okay, what we get over here is we get T1 equals square root of d over 15.69. Fine. What we get for T2 is this, but we can take the square root of 4/9 actually because they're both perfect squares. So if we take the square root of that, it becomes 2/3 times the square root of d over 15.69. Now I could evaluate this. I could try and take a square root of this. I'm not going to worry about any of that. The main part is these two guys are equivalent, okay? So since these are equivalent, the only difference is the time of 4/9 up to that distance is 2/3 as long as this. So if this would be 30 seconds, this would be 20 seconds, something like that. So it would be 2/3 of the time required to pass the cone. This is an incredibly hard question. I would actually rate this, but this is harder than anything I've ever seen on the actual SATs. I've taken 2 in the last 2 years, real ones. I'm probably going to take the March one again, and all the other real ones that I've seen that have been released in that time, I've looked over, I think 4 or 5, and this is no joke. So anyways, people ask me all the time, are the Khan Academy questions, these practice questions, the same? Or are they harder? Way harder, especially these level 3s and 4s. Okay, next. Menten Kinetics is a model. Menten Kinetics is a model that describes the rate of enzyme reactions by relating the reaction rate V, measured in micromolars per minute, a lot of jargon, to the concentration of a substrate S. I bet you none of this we need to even know. The formula is shown above, where V max is the maximum rate of the reaction and K is a constant. Which of the following is the best description of the constant K in this context? Okay, maybe I do need to understand a little bit better because, okay, let's see here. is a model that describes the rate of enzyme reactions by relating the reaction rate V, so that's my reaction rate, measured in micromolars per minute, to the concentration of a substrate, measured in millimolars. Okay. Reaction rate. The formula is shown above where V max is the maximum rate of the reaction and K is a constant. So that's concentration of a substrate. So I think it's when the concentration of the substrate. Let me think about this for a second. The concentration of the substrate goes to 0. Okay. It would be V max, but it'd be 0 over K, which is 0. The concentration is 1 of the substrate. It would be V max. It would be the maximum over K plus 1, which would almost be the... Oh, I know. It's... Okay. I'm not sure. This is really tricky. I think that... Hold on. Let me read that Vmax part again. The first, where Vmax is the maximum rate of the reaction and K is a constant. I think it has to do with the maximum rate of the reaction because it kind of checks the maximum rate. Like no matter what the maximum rate is, we have to divide by this constant K. So it's like, I think that the constant K puts it in terms of reality, where that's the maximum rate. And we could probably never reach the maximum rate based on this K value. Like if the K value was 2, even if S is 1, is 2, is whatever the concentration, we're always having to divide by something, or 0.3 or 0.4, whatever. We're always having to divide by this plus whatever this constant is, kind of where it sticks this reaction rate at some fixed point that it can't go beyond, or even in this case, or it also protects the formula from going beyond the maximum rate. Like if S were a fraction or something, it could theoretically go faster, I guess. Here's the substrate concentration at which the reaction rate is equal to 0. Oh, I see. So it's some substrate concentration. This is more specific. Which the rate of the reaction is equal to 2V max. Which the reaction is equal to 0. Let me think about that. If it's K, if that's true, then this would be, because basically for that first one to be true, that means that if I plugged in K for S, we would get 0, but that wouldn't, I don't think that would work because it'd be V max, very typical problem, K over 2K. These guys would cancel out, V max over 2. No, that doesn't make sense. I'm eliminating A, at which the rate of the reaction is equal to V max. No, it's equal to V max over 2. It's this. Whoa, this is so hard. I mean, I think that's right, but you have to think, like I said, these are not accurate problems, but you have to think to plug K in for S and then solve. And then, so look, what you get is V max times K over K plus K, right? I'm plugging in K for, if I show you over here, I'm plugging in K for S, and then you get V max times K over 2K. This cancels out and you get, K cancels out and you get V max over 2, which is 1/2. So I think that's right. Jeez. So difficult. All right, next. The price elasticity of demand is defined with the ratio of the percent decrease in demand to the percent increase in the price of a product. Above formula shows the price elasticity of demand for large appliance as a function of P, its price in dollars. Which of the following best describes the meaning of 1,000 in this context? I assume that the price can't go beyond 1,000 because, it can't go below 1,000 because if it did, we'd have negatives. So I think it's the minimum price. Okay, let's think about this for a second. When price equals 0, that's wrong. A is wrong. Okay, look, let's use this strategy here. If when price equals 0, the price elasticity equals 1,000, just plug 0 in. It becomes 0 over negative 1,000, which is 0. And that does not equal a price elasticity of 1,000, so that's out. B is when price equals 1, the elasticity of demand is 1,000. That's definitely ridiculous because that's 1 over 1 minus 1,000, which is 1 over negative 999. No, that makes no sense. As the price P approaches 1,000, the price elasticity of demand increases in absolute value. Got it. Okay, let's see. So let's try a couple values here. Let's try 100, 200, I don't know, 300. For P. And this is what we get for E. So when it equals 100, it's 100 over negative 900, which is negative 1/9. When we plug in 200, it's 200 over 200 minus 1,000 is negative 800, so negative 1/4. So it's increasing in, it's decreasing in value. 300 is 300 over negative 700, so negative 3/7. So it's getting smaller, but that's in the negatives. Let me try values on the other side of the coin. If I tried, let's try 3,000 and then 2,000. So 3,000 is 3,000 over 2,000, which is 3 halves. 2,000 is 2,000 over 1,000, which is 2. So the thing is, as it approaches P, as we get closer to 1,000, this would be infinite. This would be undefined. So actually here, as it approaches 1,000, the price elasticity increases. Okay. Price. Oh, in absolute value. Yes. It increases in absolute value. Yes. Because this decreases, but in its negative value. So it says the price elasticity, increases in absolute value. You see that? Because here it's approaching it from that side and it's getting bigger positive, so that's fine. Here it's actually getting bigger negative, but the absolute value is increasing. If we took absolute value, this 1/9, 1/4, 3/7. And if I plugged in 900 or something, right, it'd be 900 over 900 minus 1,000, which is 900 over negative 100, which is negative 9, which is absolute value is 9, so on and so forth. So that makes sense, hopefully. Yeah. Cool. All right, number 4. The sales, let me just see something real quick. Okay, cool. We got this crazy formula. A shoe company sells each pair of sneakers for $60 and expects to sell 3,000 pairs at this price. The sales analysts have predicted the revenue R based on the number X of $5 The sales analysts have predicted the revenue R based on the number X of $5 increases using the equation shown above. So this is number of $5 increases. So we do one $5 increase, another $5 increase. So if when it's 2, the price is 70. When it's 3, the price is 75. I think that's what it's saying. Assuming that the sales analysts have predicted the revenue accurately, for what price should the shoe company sell each pair of sneakers in order to earn the maximum value? So I've predicted the revenue accurately. We're basically trying to find the maximum. This is a parabola in upside down one going like this. We're trying to find this point based on the number x of. Oh, I get it. No. Sorry. So this is where, never mind. This is $60 is where they'd want to sell. This isn't a $5 increase from 60, I don't think. Otherwise it'd be 80. Wait a minute. See, that's the question. Okay, so I got to figure out my baseline. I know that it's 4. Okay, look, this is in vertex form, which means that this value right here is my vertex. So the X value is 4 and the Y value is 192,000. Okay. So that means X is 4 and X is the number of $5 increases, which means we should do 4 $5 increases, which theoretically should put us at a price of $80. And that will give us our maximum amount of sales, or maximum amount of revenue, excuse me, not maximum amount of sales. So the question is, are we starting at 0 or are we starting at at 60? Okay, one more second here. So that's 4, 0, that goes away. Yeah, that makes sense. Okay, I'm going to go with 80 because I think they're saying, yeah, I think we're talking about 4 $5 increases from 60, which is 80. That's correct. Yeah. So that just threw me off. That was a lot of information to process there. Okay, last but not least, these I think have all been no calculator. The administrators of a factory modeled the cumulative average construction time in minutes per engine component as a function of the total number of components. Minutes per engine component. Total number of components their employees had constructed, and using the function above. After the employees had constructed a very large number of engine components, what was the cumulative average time to construct a single component according to the model? So we have to divide it by n. So it's basically T. We could do it like this, or, oh, wait, you can actually, okay, hold on. So components constructed n. Cumulative average time. We'd have to take, so let me make sure I read this correctly. Factory model, the cumulative average construction time. Oh, I get it. It's 3.5 minutes. That is, again, these are ridiculous. I've heard that there can be a disconnect between these practice problems and the actual SAT because essentially the College Board used to give oversight, much more oversight is my understanding, to Khan Academy, and they do that less now. So I think Khan Academy is actually building these without running them by the College Board, which is why you see this disconnect in terms of the difficulty. If you can get these, you're going to kill the SAT. But I think this is pretty unrealistic as a problem. But here's what they're asking. They're saying look at this. This is just ridiculous. I constructed a very large number. I mean, come on. What they really want you to, and this is also no calculator. You can imagine when this goes to like 1 million or 1 billion, this value, and you have something less than 1 being taken to that exponent, what's happening is it's getting closer and closer to 0. So if we say a very large number, like even 1,000 or something, 0.9 is going to go to 0. So it's going to be 3.5 plus 7 times effectively approximately 0, which means that this is going to go away, which means that the time then, and this is the cumulative average time. Sorry, so I was off before. The cumulative average time is just going to go to 3.5. Pretty sure that's right. All right. That's it. Let me see if there's any questions from the folks watching. What are your thoughts on them reusing a June 4 code? I don't know. I have no idea about that question about a June form code for the December SAT. I wish I had a better idea of that. All right, guys, I hope that was helpful. Again, if you like this video, you found it helpful and useful, even though these were incredibly tough problems, make sure to click that like button. And if you want to see more SAT content from Scalar Learning, click that subscribe button. Thank you guys so much for joining, and I'll see you all next time. Take it easy.